right, guys. So review sheet's out. So first thing we're going to do is look at problems 1 through 9. 1 through 9. Tell whether each function or each equation is direct, inverse, or neither. Now we talk about direct variation. Direct variation comes in the main form of y is equal to a times x, where a is our constant amount. Now we can have this in another form of y over x is equal to a, and both of these are direct variation. Now we also have inverse variation, which comes in the form of y is equal to a divided by x. Or another variation of this is y times x is equal to a. And again, a in both cases is a constant amount. And for both of these sets of equations here to start with, we need to determine which one it is, direct or inverse variation. So if we look at these problems here, for direct, it's either going to be y is equal to a times x, or y divided by x is equal to a. Our inverse is either going to be y is equal to a over x, or x times y is equal to a. And if we look at number 1, would that be direct or inverse? This here would be direct variation. Because 8 times y is equal to x, or we could rewrite this, we can divide both sides by 8 and say that y is equal to 1 over 8 times x. Number 2 would be what? Inverse. Number 3 is neither. What's the big giveaway? Yeah. We have addition or subtraction written in the equation. It's going to be neither. Because direct and inverse variation is completely with multiplication or division. We don't have addition or subtraction with it. Number 4 would be inverse. Number 5 would be inverse again, because it matches up to our x times y. X times y is equal to a. X times y is equal to 47 halves. So it matches up with our inverse. And lastly, we would have neither, because of the addition. In any of these here, we're trying to match it up with one of the two forms that we have. Neither. Yep. Addition or subtraction is going to be neither, with direct and inverse variation. Any questions on these here? Now 7, 8, and 9, we're just still trying to determine if it's direct or inverse variation. But these here, we're specifically going to be looking at y over x is equal to a for direct, and inverse is x times y is equal to a. Because if they're direct or inverse, they need to vary by a constant amount every single time. And the way we can tell that is by either dividing the y's by the x's or multiplying the two together. And if we get a constant amount every single time, it's going to be one or the other. So for number 7, we can start out with direct variation. We can start by dividing them. So we can say 16 divided by 4 is 4. Our next one that we have is 11 divided by 5 is 2.2. Are those the same amount? No. Okay, so it's not direct variation. Now we can try inverse variation. So we'll multiply them together. 4 times 16 is 64. 5 times 11 is 55. Those are not the same, so this is neither. because we didn't get the same amount when we were dividing, we didn't get the same amount when we were multiplying, so it is neither. And we'll do the same thing with number 8. So we can start off with either one. So we can say 14 divided by 7 is 2. 22 divided by 11 is 2. 28 divided by 14 is 2. 34 divided by 17 is 2. 42 over 21 is 2. And lastly, 50 over 25 is 2. So when we divided the y's by the x's, we did get the same amount every single time, which means this would be what? Our direct variation. Any questions on 7 or 8? Now let's look at number 9. So we can start off with doing it by direct variation. 29 divided by 2 is 14.5. Well, we can do 14.5 divided by 4, but I know I'm not going to get what? 14.5. They're not going to be the same. So we can stop there. Now the other option is to multiply them together. Now 2 times 29 is 58. 4 times 14.5 is 58. 8 times 7.25 is 58. 16 times 3.625 is 58. And if we do 24 times 2.416 repeated, we get 58. And if we do the last one, we'll get close enough to it. I probably should have stopped at this one here. But what is this one going to be? The rest of them are going to be 58, which means it's what? Inverse. Now for the ones on the test, you're not going to have to approximate, especially the last one. They're all going to be the exact values one way or the other. Any questions on 1 through 9? Let's look at 10 and 11. With both of these here, we're wanting to simplify as far as possible. And when we simplify, we factor the numerator and denominator. And the first thing we always look for in factoring the numerator and denominator is greatest common factor. So, when we look at this here, 2x squared, guys, is as simplified as it gets. We can't reduce it any further because it's a single term. But if we look at the denominator, 3x squared minus 4x, they do have a greatest common factor of x that we can factor out. And if we factor an x out of 3x squared, we have 3x. Minus, we factor an x out of 4x, we have 4. Now we do have an x in common on top and bottom that will simplify. This x will simplify with one of these here, leaving us with 2x over 3x minus 4. Any questions on number 10? Number 11, a problem like it's not going to show up on the test, at least not of that complexity. I still want to look at it, guys. I still want to look at it so that we can kind of look at the process, but we're not going to be having to factor an x to the fourth. This one's going to make the denominator be 0. And there's two. One of them, x cannot be 0 because x is by itself. The other is whatever's going to make 3x minus 4 be 0. So we would add 4 to both sides. Minus 3x is equal to 4. Divide both sides by 3, so x cannot be 4/3. Because again, our restrictions are whatever is going to make the denominator be 0. Now, x minus 3, so 4x squared.
You said that we wouldn't do this one?
No, we're not going to worry about number 11.
Oh.
Yeah. 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 So, we're looking at number 12. Again, whenever we simplify these here, we need to factor the numerator and denominator completely. So we look at the denominator. X cubed and 27 are a difference of perfect cubes. X is going to be just x. Because if we take the cubed root of x to the third, we get x. If we take the cubed root of 27, we get 3. Our signs are going to be the same. Opposite always end on a positive note. For the first term, we're going to have x. Here we're going to have x squared. Here we will have x. Our second term is going to be 3. In the middle, we multiply the 3 and x together to get 3x. And the last one is 3 squared. And 3 squared is 9. Now we also need to factor the numerator, our x squared minus 7x plus 12. Since the 12 is positive, our signs are the same and match the sign of the middle term. So we have negative and negative. Our factors of x squared are x and x. Now our factors of 12 are 1 and 12, 2 and 6, or 3 and 4. We would want to use 3 and 4. Any questions on this so far? Now we do have something in common on top and bottom, which is the x minus 3, and they would simplify out, telling us that x minus 4 is over x squared plus 3x plus 9. Now our restrictions are whatever is going to make the denominator be 0. Here, x minus 3 is equal to 0. We can add 3 to both sides, telling us x cannot be 3. Now the other part that we have is the x squared plus 3x plus 9. That is the other denominator that we have. Now we can graph this to kind of see it. X squared plus 3x. x plus 9 graph. Looking at this here, does this cross the x-axis? This doesn't cross the x-axis, so is there any way that the x squared plus 3x plus 9 can be 0? No, so it doesn't have any restrictions. The other way that we know this is because this part, this quadratic, came from a difference of perfect cubes. The quadratic of a different or summed of perfect cubes is never factorable, which means it can't have zeros. There's no way for it to be a 0. So it will never have restrictions. Any questions on this here? Questions on any of the problems up to 12 so far? Now let's look at problem number 13. Now for any of these here, we do need to make sure we factor the numerator and denominator and then simplify any like terms. Now with any of these here, with simplifying or any of the factoring, I would always factor the one that we can see its factors easiest. And I would say the denominator, x squared minus 4. X squared minus 4, there's not a greatest common factor. There's not something that goes into both terms. But x squared is a perfect square. 4 is a perfect square. And since they're being subtracted, it is a difference of perfect squares. So we'll have x plus 2 and x minus 2. When we look at the numerator, x squared minus 4x minus 12, there is not a greatest common factor. There's not a number or variable we can factor out. And again, that's where I would always start, is with greatest common factors. Now the next thing we look at is the 12. Since the 12 is negative, our signs are opposite. One's positive, one's negative. Just how I ended up picking them. Won't always be 12, but worked out nicely. Now the factors of x squared are x and x. Now the factors of 12 are 1 and 12, 2 and 6, 3 and 4. 2 and 6, which one's positive, which one's negative? 2 is positive, 6 is negative, because if we want a middle term of negative 4x, we need the 6 to be negative and the 2 to be positive. Now that does give us like terms on top and bottom. So the x plus 2 and x plus 2 will simplify, leaving us with x minus 6 over x minus 2. That there is as reduced as it gets. Yeah. Yeah, no, that's as far as it gets because the x minus 6, the subtraction keeps them together. Because the only way that this would simplify further is saying x over x minus 2 minus 6 over x minus 2. With subtraction, the denominators stay the same. We break it apart, but that's not making it any simpler or helping us in any way. So we don't have to write it that way. Now our restrictions are what's going to make these two denominators be 0. For x minus 2, it would be positive 2, and for x plus 2, it would be negative 2. If it asks for restrictions, then yes. If it doesn't ask for them, then no. But this here is your final answer. X minus 6 over x minus 2. It would be the final answer. If it asks for restrictions, then yes. So if it asks to simplify and state the restrictions, we need both. If it just asks to simplify, we just need the x minus 6 over the x minus 2. Any questions on 13? Let's look at 14 next. Now when we look at this one here, we multiply, and with monomials, meaning individual terms, these monomial rational expressions, there's no addition, subtraction in any of the any numerator or either denominator. We can go on and multiply them together. Now the only number on top is 4, so we just have 4. X is the only x on top, but we do have y to the third times y. When we multiply like bases, we add the exponents. So that gives us y to the fourth. In the denominator, 8's our only number, so it moves to the front. Now we do have x squared times x, which is x to the third, and we have y. Any questions on how we multiply these two together? Now at this point we can simplify because we still need to simplify. 4 over 8 reduces to what? 1 over 2, it's 1/2. I don't necessarily put the 1 in the numerator yet. I will put it there if everything else in the numerator simplifies. Because if there's nothing else left, it's 1. 4 over 8 is... Now, whenever we divide like bases, x over x to the third, we subtract the exponents. So I normally say 3 minus 1 is 2. Is it bigger on top or bottom? So it stays on bottom. But really, we're taking 1 away from the top and bottom. The numerator simplifies out completely, and the denominator goes from having 3 to having 2. The same thing is true with y. We're removing 1 from the top and bottom. Or 4 minus 1 is 3. And since it's bigger on top, it stays on top. And if we wanted to list the restrictions, x cannot be 0 and y cannot be 0. Because x and y are both in the denominator, and since there's no addition or subtraction, it's just they can't be 0. Any questions on this here? Let's look at the next one, 15. Now this one here, we have a few more terms, so we do need to factor first. So when we look at the first one, x squared minus 4. Whenever we look at any of these individually, we do look for a greatest common factor first. Is there a greatest common factor between x squared and 4x? X, so we factor it out. And if I factor an x out of x squared, we're left with x minus an x out of 4x is 4. Now the denominator x minus 1 is as simplified as it gets because A, there is no greatest common factor between x and 1 besides 1, which doesn't really help. And the power, or the biggest exponent attached to a variable is 1. X minus 1 is as simplified as it gets. The other denominator, 2x, is a monomial. It's a single term. We can't simplify it any further. Now there is one more thing that we do need to simplify, which is the x squared plus 3x minus 4. Now there's not a greatest common factor. Kind of the giveaway is 1 is that x squared, there's not a number in front of it, and 2, all three terms don't have a variable. So there's no greatest common factor. But we can factor it. 2 sets of parentheses. Since the 4 is negative, our signs are opposite. One's positive, one's negative. Our factors of x squared are x and x. The factors of 4 are 1 and 4 or 2 and 2. We'd want 1 and 4. Which one's positive, which one's negative? 4 is positive, 1 is negative. We need the 4 to be positive if we want a positive 3x. Also, for us to have any like terms, we need it to be x minus 1. As we multiply these together, we would have an x minus 1 in common on top and bottom. We also have what else in common? An x and x, which leaves us with x minus 4 times x plus 4 all over 2. And in this case, x cannot be 0 or 1. We're not going to worry about restrictions. Here it would be 0 and 1, but the test, I'm not having you list any of them. The only place that would be helpful to list is if we're solving with extraneous solutions. And that part of the test will specifically state that. Questions on 15 or 14? Questions on 14 and 15? So if we look at this next one here, again, we want to factor each of these here and then multiply and simplify. Out of the 4, the 2x squared plus 4x is probably going to be the easiest one to start with. Because if we look at 2x squared and 4x, they have a greatest common factor of 2x. 2 and 4 have a greatest common factor of 2. X squared and x have a greatest common factor of x. And if we factor that out, we're left with x plus 2. And that there is as simplified as it gets. 2x is fine. X plus 2, no other greatest common factor. The biggest exponent's 1, so we're simplified. Now the next one I would do is x squared plus 3x minus 4 for 2 reasons. 1, there is no greatest common factor, and 2, we just factored that not 2 minutes ago. Since the 4 is negative, our signs are opposite, positive and negative. Factors of x squared are x and x, and the factors of 4 that we want are 4 and 1. Now the factors of x squared plus 4x plus 4 is no greatest common factor. Nothing we can factor out of all 3 terms. Since the 4 is positive, the signs are the same and match the sign of the middle term, which would be plus and plus. Factors of x squared are x and x. And the factors of 4 are 1 and 4 or 2 and 2. Here we would want 2 and 2. And the last one we have is x squared minus 4x plus 3. Again, I just went on and drew the parentheses because A, there is no greatest common factor. There's nothing that goes into all 3. And again, just like the previous ones, not a number in front of x squared, so most likely there's not going to be one. Since the 3 is positive, the signs are the same and match the sign of the middle term, which would be negative and negative. Factors of x squared are x and x. And the factors of 3 are 1 and 3. Since the signs are the same and x are the only other 2 in there, it doesn't really matter where we put it. It's not like we have 2x and 3x where the middle term's going to be different. So we can just plug those in. And we multiply them together. Now we do have a few things in common on top and bottom. We have an x plus 2 on top and bottom. We also have n x minus 1, which leaves us with what? 2x times x plus 4 over x plus 2 times x minus 3. And that's it. Any questions on 16? And again, hopefully you've probably noticed a lot of this chapter is falling back on factoring. A lot of it's going to be falling back on factoring. (17) The denominator of the x squared plus 2x minus 8 is 1. Whenever they don't give us a denominator, it's understood to be 1. Out of these 3 here that are left, the easiest one I think to factor is x squared minus 16. Mainly because it is a difference of perfect squares. Because for x squared, it's going to be x and x. We're going to have plus and minus, and 16 would be 4 and 4. So what we're hoping for is that one of the factors of either of the 2 numerators is x plus 4 or x minus 4. Because if we have those, they will simplify. Now x squared minus x minus 12, no greatest common factor, but since the 12, the third term is negative, our signs are opposite. One's going to be positive, one's going to be negative. Our factors of x squared are x, and the factors of 12 are 3 and 4. We want the 4 to be negative, so our middle term is negative as well. And lastly, we need to factor x squared plus 2x minus 8. Now, since the 8 is negative, our signs are opposite. Factors of x squared are x and x. Now, the factors of 8 are 1 and 8 or 2 and 4. We would want 2 and 4, and the 4 would be positive, 2 would be negative because we want a middle term that's positive, so we need the plus 4. And then we would multiply them together. Now, what's in common? X minus 4 and x minus 4, x plus 4 and x plus 4. Do we have anything left in the denominator? No. So do we have to write a denominator in? No, it's understood to be 1. So all that's left is x plus 3 times x minus 2. Since there's no denominator left, we don't have to write it in. But do be careful that if everything in the numerator simplifies out, it still has to be rewritten in as 1. We have to rewrite the numerator as 1. We don't have to do it for the denominator. Any questions on 1 through 17? Division. Whenever we divide two monomial expressions or two polynomial rational expressions, the first one stays the same. We change it from division to multiplication and flip the second term. Keep, change, flip. Keep, change, flip. And then we multiply them together. So the denominator is y to the 8th times y to the 7th is y to the 15th. When the bases are the same, we add the exponents. The numerators, 32 times 8. I'm just going to grab a calculator because I think it's 256. It's 256. So we multiply those together. X to the 3rd times x to the 4th. Since the bases are the same, we add the exponents, which gives us x to the 7th times y. Now, with both of these here, there's only one thing in common on top and bottom, and that is the y. So we'll still have 256. We'll still have x to the 7th. But if I take one y away on top and bottom, we're left with y to the 14th. Or as we can say, 15 minus 1 is 14. And since it's bigger on bottom, it stays on bottom. So that's it there. Any questions on this here? So monomials, either multiplication or division. Multiplication, just multiply them and then simplify. With division, like this here, keep, change, flip. Keep the first one the same, change it from division to multiplication, flip it, multiply, and simplify. So any questions on these here? Now, if we look at the next one here, 19, this one here, we do have some factoring to take place. But before we do that, we're going to keep the first one the same. Change it from division to multiplication and flip the second term. Before you start multiplying or dividing or doing any factoring, before you factor, go on and change it from division to multiplication. Keep, change, flip. Because after we do that, then we can factor. Now, it doesn't matter where we start, so I'm just going to start with the first numerator, x squared minus 3x minus 40. Since the 40 is negative, our signs are opposite, positive, negative. Factors of x squared, the only factors are x and x. Now, factors of 40 are 1 and 40, 2 and 20, 4 and 10, and then 8 and 5. It is going to be 8 and 5. And since the middle term is negative, the 8 would be negative and the 5 would be positive. I'm going to go on and continue with the first expression. So we'll move on to the x squared plus 8x minus 20. Since the 20 is negative, our signs are opposite. We'd have positive and negative. Factors of x squared are x and x. Now the factors of 20 are 1 and 20, 2 and 10, 4 and 5. We'll want 2 and 10. Positive 10 and negative 2. Because with those, we would get a positive 8x, which is the middle term we wanted. Now we can move on to the other numerator. 2 sets of parentheses. Since the 20 is positive, our signs are the same and match the sign of the middle term, so plus and plus. Factors of x squared are x and x. Factors of 20 are still the same, 1 and 20, 2 and 10, 4 and 5. Yep. And we want 2 and 10. And the last one, 2 sets of parentheses. Since the 40 is positive, our signs are the same and match the sign of the middle term, plus and plus. Factors of x squared are x and x. And the factors of 40 are 1 and 40, 2 and 20, 4 and 10, and 5 and 8. 5 and 8. Any questions on how we factored these here? Now we multiply them. Realistically, we're just connecting the two together. Now what we have in common on top and bottom is the x plus 10 and x plus 10. X plus 5 and x plus 5. And what that leaves us with is x minus 8 times x plus 2 over x minus 2 times x plus 8. Now that's as simplified as it gets. We can't really simplify further than that there. And there's no way to factor a negative out and get them to be the same. So this is as far as it goes. Any questions on any of this here? Any questions on 1 through 19? Bless you. Let's look at 20. When adding or subtracting, the denominators have to be the same. If the denominators are the same, we can add or subtract the numerators. So here, both of the denominators are 2x minus 1. So we can go on and just subtract the numerators, which means we're doing 4x squared minus 1. We're subtracting those two numerators. Is 4x squared and 1 like terms? No, so we can't subtract them. But they are difference of perfect squares. We will pick up this